Hello, everyone. This is the final course project for INEN 5345, Computer Integrated Manufacturing. Today we're going to go over the hub assembly. This has been prepared by Jeremy, Elias, and Stephen. So just some background around this project. So obviously we were tasked with picking a assembly, and then designing all the components, and then using DFA and DFM analyses and principles to optimize the design, make it more efficient, reduce cost, um, and reduce features just to make machinability easier and overall just a better design. So for the hub assembly itself, we design the inner and outer hubs like you would see on a car. This would include the axle studs, the input shaft, the wheel, the brake disc, the bearings, so on and so forth. And then obviously we're going to use these DFM and DFA principles to optimize the design, reduce cost, and simplify, the overall design and assembly. So this is the initial design. Um, from the picture, you can see all the different components. So obviously you start with the outer hub, which is furthest right, which is green. This holds the angular bearing for the wheel rotation. And then as you work left, you'll see from the exploded view the axle studs. And these are press fit into the outer hub, which is a circular bolt pattern that you see on a normal car. And these studs are what hold the brake disc, wheel, and lug nuts and secure all those components together on the machine. Obviously, this holds all the shear force during, the rotary motion of a wheel. Okay, so model components and function. I think we all kind of know what this is, but the wheel obviously supports the tire and transmits torque to the road. The rotor provides a friction braking force to the wheel and vehicle itself against the road. The inner hub connects the bearing to the machine frame. So that's the furthest right or the green um, component we saw in the slide before. Then you have the outer hub, which transfers rotation from the drivetrain or input shaft. And then you have the lug nuts and studs that hold the rotational shear force and apply it to the wheel. Okay, so manufacturing plan for the part. Obviously, for this course, we've been using Fusion 360 to design and model assemblies. And then we've been using the manufacturing module to generate the CAM tool pathways for CNC machines or lathes. Um, and you'll see what we did in the next slide. So for the DFM and DFA analysis, what is it? Why is it important? So obviously the design analysis is used to reduce manufacturing costs and improve efficiency. This can also reduce lead times, and improve customer satisfaction, so on and so forth. For our um, design for manufacturing, you can see all the components on the right in the table. So the original design um, called for the lug nuts, the studs, the inner and outer hubs, the wheel, angular bearing, and rotor, which is the column, you can call it C or column 3. So for the assembly, you had 9 total features for this component. You also had 5 for the lug nut, so on and so forth. And then down here, you have the total features for the whole assembly. And then obviously, when we did our design analysis, we reduced the overall number of features in the assembly to 47. Um, there is a few different components that we redesigned to reduce the amount of features, and that was the outer hub and the wheel itself. Um, you know, obviously, reducing features does make it easier to uh, design and modify drawings. You could argue that changing the amount of features doesn't really benefit the end user or the machinist. Obviously, like you can do numerous features and have it all in one revolve. So just because you have less features doesn't necessarily mean it's more cost efficient. So for the design for assembly, what we did was basically redesign the assembly to eliminate the lug nuts and uh, the axle studs that connect to the outer hub. So on the left, you can see the axle studs here that go through the hub through the circular bolt pattern. And those obviously transfer through the rotor itself and the wheel. And then you have the lug nuts. And this obviously holds all the three components together and then transfers the torque to the wheel. And what we did in the new design is we basically eliminated the need for the axle studs and the lug nuts. And how we did that was we put a large keyway on the inner hub, excuse me, the outer hub, which will transfer and lock the brake disc to the hub itself, along with the wheel to the hub. And then obviously this is the male keyway. All these will be machined to have the female keyways. And then the final fastening method would be a singular bolt um, that clamps to the wheel and to the hub and transfers all that torque through that keyway itself. But by doing this, you actually eliminate the need for all the circular bolt pattern features on the wheel, brake disc, and outer hub. And likewise, you get to eliminate two components from the assembly, two types of components. It's actually nine in total. If you include the bolt that we made, um, you have five and five, and then you're adding one, so it's really nine. So you can see the difference up here. You have how many pieces are required from the initial assembly, which is 15. And then after we modified the assembly for the keyway, we obsoleted two components. Um, and then the total number of pieces in the assembly is now six. So there's just some key changes and takeaways. We reduced the amount of components needed, and we also reduced the total assembly cost by 10%, which I'll touch on in the next slide. So for the DFA cost analysis, what I did was I took all the parts from above on the initial and modified, and I got costs for each part through a website called Xometry. It's an online manufacturing for stamped metals. They do CNC, lathes, laser, um, you name it, they pretty much have it. So there are some assumptions with this. All basic tolerances were 5 thousandths across every component, initial and modified. All materials were kept constant from each design, so there's no changes in cost based on what raw material was used. And obviously, all the quotes were from Xometry. Um, so with that, you can see the cost breakdown from the initial. So each lug nut was $90. Each, excuse me, each stud was $90. Each lug nut was 41. The inner hub, outer hub costs, wheel, so on and so forth. And then obviously with the modified version, we eliminated these two components. So you saved 5 times 90 and then 5 times 41, which when you extrapolate down, it comes to about $400. So the percentage difference between the two is about 10% of the total assembly cost, um, which we're saving per assembly. So if you think about that per car, that's 2 grand, or across the manufacturing line, that could be tens of thousands. Okay, so last is just a quick summary and key takeaways from our design analysis. I believe our objectives were achieved based on the data we derived from and extrapolated out in this PowerPoint. Um, the DFM and DFA reduced machining complexity and machining costs for our assemblies, which was proven above. We also obsoleted 9 total components from the initial design when we modified it for the keyway. And then 15 total features were removed from various components throughout the assembly. And all of this achieved a 10% cost reduction per assembly. And that concludes the PowerPoint for this project. Um, this is just a few uh, pictures of the model that we did. This is just an exploded view of each component, lug nuts, wheel, brake disc. This is the outer hub, your 5 axle studs, your bearing, and then your inner hub that connects the vehicle frame. So this is obviously the first design, and obviously the second design. Um, the hub itself, the flange and secondary bolt pattern was removed, and this keyway was added. Um, Obviously, the bearings are pressed onto this. This also bolts onto that as well as a press fit. It keeps everything in motion and secured. And then the keyway goes through the brake disc, the wheel. I don't know if you can see that or not. And then the bolt keeps everything together. And this is obviously the modified version. So we eliminated 2 components, 9 in total per assembly. And that concludes the project for hub assembly by Jeremy, Alias, and Stephen. Um, Thank you.